हाय स्टूडेंट्स, तो आज हम एकलव्य एंट्रेंस टेस्ट का पेपर 1 सॉल्व करने वाले हैं एंड आई विल स्टिक टू इंग्लिश बिकॉज आई नो दैट मेनी ऑफ द स्टूडेंट्स मे नॉट अंडरस्टैंड हिंदी. सो दिस इज Eklavya Entrance Test-1 that happened on September 22, 2024, and let's begin. So this was the first question. So there is a sheet which is a uniformly charged sheet which has charge density of sigma coulomb per meter square, and then there is a sphere, a uniformly charged non-conducting sphere which is kept in front of the sheet. The radius of the sphere is r and it has the same surface charge density as present on the sheet. Okay, so the question describes an infinite non-conducting sheet with a uniform surface charge density. Okay, uniformly charged non-conducting spherical shell centered at a point A. So because it is a uniformly charged non-conducting shell, therefore there will be no redistribution of charge and it will continue to be a uniformly charged shell. Okay, now coordinates of A is given r, it's given, and it is given that A is greater than root 2r, where A is the center of the circle. Okay, x coordinate of the center of the circle. It's more than root 2r. Okay, we have to select the incorrect alternative, so pay attention to that we have to select incorrect alternative, not the correct one. Okay, so there is only one null point in space at a finite distance. So we don't have to consider distances which are very large away, because which are very away, which are large distances from these two structures, because at those points we can't say that null point is there. Okay, this sheet extends up to infinity, will not be able to comment. Okay, now so there is only null point in space. So if there is any possibility of getting a null point, that has to be on this axis. Do you understand this? Because only in this axis the two electric fields are in opposite direction. At all other points, either the two fields are not anti-parallel, like they are making some angle with each other, or they are in the same direction. For example, if I consider a point here, then the two electric fields are in the same direction. If I consider a point here, then they are two in the same direction. If I consider any other point which is not on this straight line, then the electric field will be in different direction, and therefore they cannot cancel out each other. Because for two vectors to cancel out each other, it is mandatory that they should be on opposite direction. So the only possibility is the possibility that lies here. Now what we have to check is whether we get a null point here or not. So let's say at a distance x, I'm trying to write the electric field due to the two. I'll see whether their magnitude matches or not. So the sheet will produce a uniform electric field that will be given by sigma by 2 epsilon naught, and the electric field of the sphere at a distance x from the origin. Okay, so if the distance is x from the origin, then the distance from the center of the sphere, this distance would be a minus x. Okay, this distance would be a minus x. Okay, so what will I write? I will write k, that is sigma by 4 pi epsilon naught, and the total charge of the sphere, that would be sigma 4 pi r square. Okay, so kq divided by distance square. Distance is a minus x and square of this. Okay, so let me get rid of this k. Let me get rid of this k, and instead of that, let me write 4 pi epsilon naught here. I'm writing epsilon naught here. So I'll try to find the value of x. I'll see what I'll check what I get. So if we do this, then see, this sigma gets cancelled. Okay, this 4 pi gets cancelled with this 4 pi, this epsilon naught gets cancelled with this epsilon naught, and we are left with a minus x square by 2 is equals to r square. Okay, so I can take root on both sides. So a minus x by root 2 is equals to, or I'll bring this root 2 on this side, so plus minus root 2r. So from here we get the value of x as, one of the value that we get is, or the two value that we get is, that is a plus minus or minus plus, whatever you want to write, root 2r. Okay, so if I choose the plus sign, if I think about the a plus root 2r value, then this is more than a. If this is more than a, we are talking about a point which is towards the right of the center of the sphere, so this cannot be there. And if I take the other value, a minus root 2r, the question says that a is greater than root 2r. So if a is greater than root 2r, a minus root 2r will definitely give me a positive answer. So we will get a point somewhere here. Okay, we will get a point somewhere here. A minus root 2r will be a positive number. Okay, and a minus root 2r. Okay, so from a we are subtracting root 2r, so that would be a point somewhere here only. So this option is correct. Okay, there is only one null point in space. This is correct, and therefore this will not be the answer. We are looking for the incorrect options. This is correct. Uniform electric field exists only within the spherical region. Okay, again guys, for any point outside the sphere, the electric field will comprise of two electric fields, like it will be the superposition of two fields. One is the uniform field of the infinite sheet and the other is the non-uniform field of the sphere. So a uniform field superimposed with a non-uniform field will give me a non-uniform field. So outside the sphere the field is definitely non-uniform. Within the sphere, the contribution from the sphere will be 0, and therefore within the sphere we are going to get a uniform electric field, and that will be the field produced by the infinite sheet. Okay, so uniform electric field exists only within the spherical region. Yeah, again this is correct, and therefore this is not the answer. Okay, then there does not exist any null point within the spherical region. Again this statement is correct. Within the spherical region the field is uniform, and the value of that uniform field is sigma by 2 epsilon naught. So there does not exist any null point within the spherical region. Again correct, yes. So A, B, C are correct. D has to be the incorrect one. D has to be the answer. Let's check. The electric field vector is parallel or anti-parallel to I cap only for points lying on the x-axis. Okay, the electric field vector is parallel or anti-parallel to, so D option says that if a point is not on x-axis, then at such a point the electric field will not be parallel to x-axis, which is wrong, because if I take any point in the spherical region which is not on the x-axis, so at such point also the field is parallel to the x-axis, and therefore D option becomes incorrect, and therefore D option becomes the answer. So the answer to the first question would be option D. Okay, so that's the answer to the first question. Now we'll have a look at the second question. Okay, so which of the following is sufficient condition to declare two resistance in a circuit as connected parallel to each other? Okay, so potential difference across the two is same. So guys, for this is a theoretical question. You should be aware, like to answer this question you should be aware of this theoretical point, that if there is a resistance R1 and if there is a resistance R2, okay, let's say the potential at this end is, let's say, 10 volt, and the potential here is 20 volt, and let's say the potential here is 35 volt and the potential here is 45 volt. Okay, so the difference is same. The difference of potential is 10 volt here, 10 volt here. Okay, some of you might say that they are connected parallelly because some of you have been taught to just check the potential difference, but guys, no. If the situation is this, we do not call the resistances to be connected in parallel. For having parallel connection, it is essential that if one end is having a potential of 10 volt or whatever, let's say V1, then the one of the ends of the other resistance should also have a value of 10 volt. And similarly, if this end has a value of 20 volt, then the other end of this resistance needs to have a value of 20 volt. So across the two is same, potential difference across the two is same. This is not sufficient condition. Okay, if they are connected parallelly, okay, if they are connected parallelly, then the potential difference will be same. But if the potential difference is same, we can't conclude that the resistances are connected parallelly. Okay, so no, ratio of the current is an inverse ratio of the resistance. Again guys, that can happen by a matter of chance also. For example, it is possible that two resistances are not connected parallelly and yet the ratio in them, okay, there can be a circuit like this, you know, there can be a circuit like this, you know, anything, something like this, and it is possible that this resistance may be 5 ohm, this is 10 ohm, and it may happen that 2 ampere current flows through here, and let's say 1 ampere current flow. So we can manage this, it can be managed. So ratio of the current in them is inverse ratio. It can happen even when the resistances are not connected parallelly. Okay, one end is connected to the other, one end is connected together. So only if one end is connected together and the other end is not connected together, okay, then also we can't say that these two resistances are connected parallelly. So none of them, which of the following is sufficient condition? So they are not sufficient. Sufficient means that if the condition is satisfied, we don't have to check any other condition and we can directly conclude that the resistances are connected parallelly. None of these conditions is sufficient. So again, the answer to this question should be option D. Okay, so this is also D. Okay, next question. A particle with charge q and mass m is traveling with a velocity v naught I cap on the negative x-axis. Magnetic field exists in space as shown as given below. So there is a description of magnetic field which is given here, which says that B is equals to 0 for negative x. So if I make the coordinate system here, if let's say this is everything okay, okay, if I say that this is, what is happening, strange, okay, if this is x-axis, Okay, if this is x-axis, so according to the question, magnetic field is 0 in this region. Okay, magnetic field is 0 for negative x. Then it is minus b naught k for x, for 0 to r by 2. So let's say r by 2 is somewhere here. Okay, and let's say this is y-axis, which will make z-axis coming out of the screen, and the magnetic field is minus b naught k. So in this region, the magnetic field will be inwards. Okay, in this region, the magnetic field will be denoted by crosses. Okay, then b is equals to 0 from r by 2 to r by 2 plus d. So now there is a region of width d in which the magnetic field is again 0. Okay, the magnetic field is again 0, and then plus b naught k for r by 2 plus d. So again, there is a region of the same width r by 2. So the width of this region was r by 2, the width of this region is again r by 2, and now the field is plus b naught k. So I will make dots here. So this is the kind of magnetic field that we are having. And r, what is r? It is mv naught by qb. So notice that this r is the same radius that we get when a charged particle moves in a magnetic field. Okay, all right. Now some statements are given below. Time spent. So the particle was traveling along the negative x-axis. So the particle was probably here. It has a v naught I cap velocity, so it was coming like this. So the moment it enters into the magnetic field, what happens? The moment it enters, there is a magnetic field in the inward direction. The velocity is towards right, and the charge is positive. So it will start deflecting upward. It will start moving on a circle of radius r. Okay, so somewhere here, like if this distance is r by 2, then the radius would be double of this distance. Okay, so this is r. So it will start moving like this, and then it will come out from here. Because there is no magnetic field, it will travel on a straight line. And then what happens when it enters this region? Now the magnetic field is outward, the velocity is this. So the center of the circle will lie here. Okay, and the center will be r. Let me check the angles. So this is r by 2 and this is r. So this angle will turn out to be 30 degree. Notice this, r sine 30 will become r by 2. So this is 30 degree. If this is 30, this is 30. If this is 30, then this is 60, then this is 30. So this angle will again be 30. Okay, and this angle is 30, then this angle is 60, then this angle is 30. Okay, if this angle is 30, the radius will be r. So where will the circle r sign? So again guys, this distance would be r. Okay, and it will start moving in a circle like this. Again it will deviate by 30 degree and it will come out like this. So this is the trajectory that the particle will take. Okay, now this portion is a straight portion. Okay, so time spent in magnetic field is independent of d. So the magnetic field was here, the magnetic field was here. So these two places had the magnetic field. Okay, so time spent in magnetic field, I think that is independent of d. That's correct. Okay, because the angle spent here was 30 degree, the angle spent here was 30 degree, and this is independent of the width of this region. No matter how wide this region is, in both the region 30 degree will be considered. So the time spent in magnet is independent of d. That's correct. Deviation produces independent of d. Again, that is correct. The deviation is 0 after crossing the entire region. Okay, time taken by the particle to move from x equals to 0 to x equals to r plus d is independent. This is wrong. So time spent in this region is it's fixed. It would be what? T by 12. If the time period of the entire revolution is capital T, then covering 30 degree will require T by 12 time. So T by 12 here, T by 12 here. But then the time spent here will depend upon this distance divided by the speed v naught, as the speed doesn't change, and this distance will depend upon the width. It would be actually how much? It would be d sec 30. Okay, this width would be d sec 30. So d sec 30 divided by v naught will be the time that the particle spends in this region, and therefore the time taken by the particle to move from x equals to 0 to x equals to r plus d is independent of d. That is wrong. So statement 1 is correct, statement 2 is correct, statement 3 is wrong. So the correct statements are 1 and 2. Option A should be the right answer to this. Okay, so we are going to check. Yeah, option A is the correct one. All right, everyone. So here's the trajectory that we concluded. The particle is going to move on. Okay, next, metal rods are used to form alphabet V, and then two V are used to form alphabet W. So we first made a V-shaped structure, and then we used two of these structure to create a W-shaped structure. Okay, now the question says both objects are rotated as shown. Okay, uniform magnetic field exists perpendicular to the plane of the object. So there is a uniform magnetic field maybe in this direction going into the screen. Okay, so guys, the concept that has been used in framing of this question is that there is a random shaped wire, and if it is rotating with any omega in a region of magnetic field, all right, then what happens? Different points of this object will move on different circles. For example, this point will trace a circle like this point will trace a circle like this point will trace a circle like this, and so on. So different points will move on the circles of different radius. Of course, I have drawn it with hand. They don't look to be good circles. So the potential difference between any two chosen point will be dependent on the radii of the circle on which these points are moving. Okay, how do we write the potential difference? So the potential difference, or the magnitude of the potential difference, is written as omega b by 2, and then it is like mod of rx square minus ry square. So what determines the potential difference is the radius of the circle on which these points are moving. Let me just check. Yeah, everything is okay. So given all this scenario, Vx minus Va is equals to Vb minus Vy. That's certainly not correct, because this separation is different from this one. Okay, let me get rid of okay guys, I need to make it a bit bigger. Yeah, stick it a bit higher, and let me erase this so that we can get space to write. Okay, all right. So so notice this, guys, that when we are trying to write Va minus Vx mod, okay, it would be omega b, and whatever this distance is, let this distance be L. So it would be L square by 2, because Ra is 0. And when we are trying to find out Vb minus Vy mod, notice that this distance will be 2L. Okay, this distance will be 2L. So it will be omega b 2L square by 2, or in other words, it would be 4 times of Va minus Vx. So let's see if we have such options. So Vx minus, so in all the options we are comparing Vx minus Va and Vb minus Vy. So we are comparing the same thing in all the options. So this is incorrect, and option C seems to be the correct one. So option C will be the right answer. Is that okay, everyone? Okay. Now let's go to question number 5. Okay. So this question says, as an infinite wire carrying current I lies along the y-axis, a current carrying metal rod has its end at A0B and A0 minus B. Let's draw the figure. Okay. So let me imagine it, A0 and B. Okay. So the situation is somewhat like this. Let me draw it. Okay. So if this is x-axis and if this is y-axis, okay, and the current is flowing along the y-axis, let me darken it a bit. Okay, and the current is flowing along y-axis. So let's say this is the current I. The question doesn't specifically say that it is moving in the plus y direction. Let's assume for the like I'll try to answer it without using the direction. Let's see what happens. And so the rod has ends A and B. So A comma 0 comma B, and so the rod is in the xz plane. Okay, this is end A and this is end B. In other words, the rod and the wire, they are skew with respect to each other. For example, if this is the wire, then the rod is like this. Are you getting it? The rod is like this. So skew positions. So this arrangement is called skew. Okay. So if I look at this figure from top, if I am looking at this figure, if I am observing this figure from the top, the wire will appear as a dot to me. Let me draw it here. So the wire will appear as a dot to me. Okay, and the x-axis will be in this direction. The z-axis will be in this direction. This wire is actually the y-axis, which appears in the form of a dot to me. And the rod will be visible to me here. Okay, this end will be A and this end will be B. This is the situation. Okay, so infinite wire carrying current I lies along the current carrying metal. So this rod also carries current. Okay, and again the direction in both is not given to us. Now the net torque on the rod is 0. Let's try to understand what will happen. For that, see this wire, if let's say if the current is outward, it will produce anti-clockwise circles. I'll not put direction on the circle, or let us put, okay, let us put, so these are the magnetic field lines, okay, these are the magnetic field lines produced by the wire. Okay, now notice guys what happens. Let's say the current in this wire, let's say it is in upward direction, let's say this is I2. Okay, so if I divide this metal rod into segments, then you will notice that, and let's also put some arrows here. So you will notice that on this segment, okay, magnetic field is in this direction, current is, so it will experience an inward force, like into the screen in this figure. So this half of the rod will experience an inward force, and here magnetic field is in this direction, current is going like this, so this portion will experience an outward force. So if this is rod, this half is experiencing inward force and this half is experiencing outward force, so there is definitely a torque on this, and moreover the net force is zero. Whatever situation this half of the rod is experiencing, the same situation this half of the rod is experiencing in the opposite direction, so the net force is zero, but the net torque is not zero. So net torque on the rod is zero, wrong. Net force is zero, correct. Okay, net force on every small element of the rod is zero, that's incorrect. Small segments, they are experiencing force. Okay, neither the net force nor net torque is zero. So out of these four options, only B is correct, all other three are wrong. Okay, so B option will be the right answer. Okay, now so this actually figure depicts what I have just explained you. Okay, now let's come to this circuit. Okay, so what does this question says? Power factor of the given circuit is minimum for, so there are three circuits, circuit P, circuit Q, circuit T. Okay, and omega L, so basically this is XL, and this is 2 times of XC, this is 2 times of XC, which is 2 times of R. So all this information has been given to us. Okay, and yeah, okay, all right. Now in the first case, what will be the power factor? So for the how do we write power factor? So power factor cos phi is R divided by Z. Okay, it is R divided by Z, cos phi. All right, R divided by Z. And how do we write Z in a series LCR circuit? So that will be written as R divided by root of R square plus XL minus XC square. So while calculating power factor of any circuit, we'll convert everything in terms of R. So for the first circuit, okay, cos phi for circuit P, it would be R divided by XL minus XC. XL is 2R, XC is equal to R. XL minus XC will be equal to R. So R square plus R square root of that. So we will get root 2R here. So it will be 1 upon root 2. So that is the power factor of the first circuit. For the second circuit, R and C is there. So this is also R, this is also R. And so the value of Z will be again, so for second circuit also the same value of power factor we are going to get. In this case the power factor will be in the third case R divided by root of R square plus 2R square. Okay, so in this case in the denominator we are going to get root 5R. So this is less. So the power factor is minimum for circuit T will be the answer. So I believe this was a very simple question, guys. I believe many of you would have got answers in this question. Like you would have been able to fetch marks for this question. Okay, now let's come to the next question, question number 7. So instantaneous potential difference across LCR given at t equal to 0. So at a certain instant we have been told that the instantaneous potential difference across LCR is this. We have to select the correct alternative for t equal to 0. This is a good question actually. So guys, let us say that the current flowing in this circuit is let's say I0 sine and omega t plus phi. Okay, so this is the current flowing in the circuit. Okay, so the instantaneous value VL, okay, the expression for that should be I0 into XL and then sine of omega t plus phi minus pi by 2. Notice, because just a minute. For a inductor, the current lags EMF. So if current lags EMF, so this should be plus actually. Okay. Yeah. Yeah. So current lags EMF, so this should be the case. Okay. Then how will we write VC? So VC will be written as X naught into XC and then sine of omega t plus phi minus pi by 2, because for an inductor current lead, for a capacitor current leads the voltage across it, so minus pi by 2. For resistance, let me write it here. So VR would be I naught R into sine of omega t plus phi. The current in a resistor is in phase with the potential difference across it. So we have been told that VL is 10 volt. Okay, so this value is 10 volt. Okay, this value is what? This value is 2 volt. Okay, and this value is 6 volt. Okay, so this is the scenario. Now the instantaneous potential difference between AB. Now AB point, so we are trying to write instantaneous potential difference between VA, AB, RMS value of the source voltage. Instantaneous potential difference between AB can be 16. Okay, so when we are trying to write instantaneous potential difference, see, when we cross the inductor, if there is a potential drop, if there is a potential drop of 6 volt, okay, then on crossing the capacitor, okay, then on crossing the capacitor, this value can either be plus 2 or minus 2. It can either be like it can either be plus 2 or minus 2, and across the inductor it will be just opposite of that. Okay, it will be opposite of that, so it will be minus 10 or plus 10. So I'll reverse the signs. Okay, so the potential difference between A and B, the possible values are like 6 minus 2 plus 10 or 6 plus 2 minus 10. So these are the two possibilities. Okay, you can say that here also we should change the sign. I think that will give us the same answer. So here the answer that we are getting is 14 volt, and here the answer that we will get is what? 2 volts, minus 2 volts. So let's focus on the magnitude. So the instantaneous potential difference, 1, we are definitely not getting 1. If you want to try with minus and plus sign also, I think you will still end up with these values only. Like if I put a minus sign here, the value that I get is 2 volt. If I put a minus sign here, the value that I get is minus 14 volts. So magnitude wise, the only possible magnitudes are 14 and 2. The only possible magnitudes for potential difference across the A and B. So instantaneous potential difference can be 1 volt. No, it cannot be 1 volt. 15, no, it cannot be 15. RMS value of the source voltage is 10. Again guys, that is not correct. Like we can't calculate RMS value using the data given to us. Okay, the instantaneous potential difference can be 14, so D option is there. D option will be correct, and since it is a single option correct question, I can rest assured that D has to be correct. Like we don't have to really spend time on option C trying to prove or disprove it. Okay, now comes question number 8. Now what does this question says? This says a charge of 10 microcoulomb is present at 2, 3, 4 electric field at B due to this charge. So guys, it's a very simple question that utilizes the vector form of electric field or vector form of Coulomb's law. Okay, so how do we write it? So E vector is written as K, Q, then R. Let's say if the charge is at A, and we are trying to find out electric field at B, okay, then Q has to be substituted with sign, along with the sign. So K, Q, R, B, A vector. Okay, K, Q, R, B, A vector divided by mod of R, B, A vector cube. That gives us the answer. So we have to finish this calculation. Okay, obviously to finish this calculation, we first need to find out RBA vector. Let's do that. Okay, so let me get some space by erasing this. Okay, so how do we write RBA vector? So RBA vector would be coordinates of B minus coordinates of A. So 4 minus 2, that's 2i cap. Then 3 minus 3 is 0, and 2 minus 4 is minus 2k cap. Okay, so we know the magnitude of RB also, so let me substitute the values here. K is 9 into 10 raised to power 9, Q is 10 micro, so and it's a positive, negative charge is not given, so it's positive. So this, and then RBA vector is 2I cap minus 2K cap, and divided by magnitude of RBA, that is 2 root 2, 2 root 2 cube. So 2 cube will become 8, and root 2 cube will again become 2 root 2. Okay, so 2 root 2 cube, 2 cube is 8, root 2 cube is 2 root 2. So this is what we are getting, and let's see what it becomes. So 1 2 I can remove from here, I can cancel this, and then this becomes what, 10 raised to power 10, 10 raised to power 4. Okay, so we are getting 9 upon 8 root 2 into 10 raised to power 4, and then I cap minus K cap. So this is what we are getting. Let's check whether this is present in the option. A option is I minus J. I will not bother about checking the value. This is only J. I will not bother about checking it. Option C is I minus K, and the value, okay, the value is 9 into 10 raised to power minus 4 into, okay. So I think between here, I think D option should be correct. I doubt whether, okay, let's see what is the answer given. So guys, I think in option C, this power, what I have got here is not right. This power should have been plus 4. Okay, and in the actual paper, you would have got the power of plus 4. Okay, so don't worry about this, but what is written here, there is a misprint in that. Okay, all right. Okay, now system of parallel plates, question number 9. All right, system of parallel large conducting plate is shown. Okay, A and C are connected by a metal wire. Okay guys, so we have 4 plates and the charges on them are 10 coulomb, 20 coulomb, minus 24 plus 32. How do we solve these questions? So guys, in a system of parallel plates, there are few rules that we have to follow. The first rule says that the outermost plates of the system will contain half of the total charge of the system. For example, the total charge here is 30, 10 plus 20, that's 30, 30 minus 24, that's 6, 6 plus 32, that's 38, half of 38 is 19. So the outermost surface will have a charge of 19 and 19 coulomb, and even if we connect A and C, all right, the net charge of the system is going to remain this only, because there may be an exchange of charge between A and C, but that is not going to alter the net charge of the system. So the outermost surfaces, they remain unaffected. But what happens when we connect A and C? Now we are not sure that 10 coulomb charge will stay on A. Some of that charge may have moved to C. So we assume an unknown value here. Let's say the charge here was X. And again, in a system of parallel plates, it is mandatory that the facing surfaces should have equal and opposite charge. So if there is X here, then there is minus X here. This plate is isolated, so the charge 20 coulomb on this will remain conserved. So if minus X is present here, then 20 plus X has to be present on this surface, 20 plus X, because the total charge of this plate has to be 20. My 20 doesn't look like 20. Okay. Okay, and then the facing surface will have a charge of minus 20 minus X. Okay, minus 20 minus X. And what about this charge? So here is 19, the total was 32. So 13 coulomb. 13 coulomb will be on this side and minus 13 will be on this side. Now we need to find the value of X. How do we do that? So we start from this plate. Okay, we start from this plate and we jump. So since A and C are connected, we start from A, we try to go towards C, and whenever we move through the air, we check what is the charge on the landing surface. So when we move through air, we land on this surface. So the charge on the landing surface is minus X. We multiply it with the distance that we have covered in air, that is D. And then again, when we move from B to C, okay, then the charge on the landing surface is minus 20 minus X, and we again multiply it with the distance, which is again D, and then we equate it to 0. So from here, D gets, okay guys, D gets cancelled, and what we end up with is minus 20 is equals to, minus 20 is equals to 2X. So X is minus 10. Okay, so we get the value of X as minus 10. So if X is minus 10, let's read the options now. Magnitude of charge on the left surface of B, okay, that would be 10. is equal to the charge on the right surface of B. That's correct. Okay, that's correct. Okay, so A option is correct. The other three should be incorrect. Yeah, so A option is correct. So these two becomes incorrect. A option is the answer then. Okay, so option A is the answer, everyone. Okay, now question number 10. Okay, an electric field is given by E is equals to 3x square y square z I cap plus some function is written, potential function to corresponding to. How do we do this question? So these questions are done by this, like if electric field is given to us, we write potential as negative of integral of minus E dot ds, and keep in mind that ds can always be written as dx I cap plus dy j cap plus dz k cap. We can always write this. Okay, plus v naught, let's say. Okay, some constant. So when we do this, minus E dot ds, so E dot ds will give us 3x square y square z dx. Okay, then plus 2x cube yz dy. Okay, and then plus x cube y square dz. So this entire thing we are going to get, and this is what? This is nothing but it is d of x cube y square z. You'll have to verify this yourself. If I differentiate this quantity, I get this. If I differentiate x cube y square z, then first I will differentiate the x cube term. So I will get 3x square into y square z with dx. If I differentiate this with respect to y, okay, then I will get x cube into 2y into z with a dy. We got this. If I differentiate this with respect to z, I get x cube y square dz. So alright, the v naught will be there. I'm not writing it right now. So when we finish this integration, we end up with minus x cube y square z plus v naught, and the question says that at the function assume v origin as 0, so I put x y z as 0 and I get a potential of 0, so v naught also becomes 0. So the final answer would be option A. The final answer would be option A, minus x cube y square z. Okay, another method to attempt this question in the examination would have been to differentiate the options given to you. For example, if v is given to you as a function of x, y, z, okay, then you can check this out, like the electric field is given as minus of del v by del x I cap plus del v by del y j cap plus del v by del z k cap. Okay, so you can use this and you can check the options, you will get the answer. Okay, now question number 11, which is an integer type question. Okay, so three identical particles of charge q lie at the vertices of an equilateral triangle and a fourth particle lies at the centroid of the triangle. All right, all the particles are in equilibrium under the influence of the mutual forces. The ratio of the net charge of the system is the ratio of the net charge of the system and q is this much, the value of A. All right guys, so the situation is this. The situation is this: we have three identical particles. Okay, so if there are three identical particles, we already know that they will produce a zero electric field at the centroid, which basically means that whatever you keep at the centroid, that will not experience any force. So that particle is definitely in equilibrium. But once you have kept a charge here and then you try to check the equilibrium of the particles which are kept at the vertices, we have to do something about that. So let's talk about this particle. So this particle will experience electric force due to this one. Let's say in this direction, let's say it is F. Due to this one, again it will be F, and then this particle must apply a force in this direction, let's say F1, such that F1 becomes equal to the resultant of these two, and the resultant of these two would be F cos 30 into 2, because the resultant, this angle is 30, this angle is 30, so F cos 30 into 2. Okay, so this is what we have to solve. So cos 30 is root 3 by 2, so root 3 F. So F1 should become equal to root 3F. Now we have to find out the value of F1. Now to find out the value of F1, we need this distance. We need the distance of centroid from this vertex. How much is this distance? So if this length is A, then the height would be root 3A by 2, and this is 2 by 3. This is 2 by 3 of the height. So I will write F1 as KQ. Let's say this is capital Q, and keep in mind that it needs to have a sign which is opposite to that of Q. Only then the attraction will take place. Right now I'm writing magnitude here. So KQQ, is it visible? Yeah. KQQ divided by this distance, square of this distance. So this is what? This is 2 by 3. So when I do 2 by 3 of this, I end up getting a by root 3. Okay, so 2 by 3, yeah, square of this should be same as root 3 into f is k q square by a square. So when I try to solve this, okay, when I try to solve this, this k gets cancelled, 1 q gets cancelled, a square will get cancelled, and we will be left with capital Q into 3 is equals to root 3q. Okay, so capital Q will be q upon root 3. Capital Q will be q upon root 3. Now the question says the ratio of the net charge of the system. Okay, so how do we get the net charge of the system? The net charge of the system is like the net charge will be 3q, okay, plus minus q. So this is 3q minus q by root 3. We obtained this q by root 3, correct? Okay, so it turns out to be q into 3 root 3 minus 1 upon root 3, and therefore the ratio of q net by q will simply be this number. So this is 3 root 3 minus 1 upon root 3, and when I compare this with the given arrangement, I discover that a should be equal to 3. So 3 would be the right answer. Okay, so the right answer to this question would be 3. Now question number 12. Okay, what does this question says? So uniformly charged wire of density lambda coulomb per meter creates a planar figure in the shape of alphabet D. Okay, so this is an alphabet T. Segments are either straight or circular. Okay, magnitude of the electric field strength at O is this much, the value of A is again. Okay, so guys, this is a straight segment of length 2r, this is a straight segment of length r, then this is a semicircle. Okay, and this is point O. All right, so what will happen here? Should I increase the size of this figure? I think that will make, okay, okay, let it be. So let me call this as 1, let me call this as 2, let me call this as 3, and let me call this as 4. So I've numbered the segments. So the first segment will only create an electric field in this direction. Okay, and let me call this as E1, and what will be the magnitude of this? It would be, the general formula is k lambda by r, where r is this distance. Okay, and then mod of sine of this angle, okay, which would be 45 degree. Okay, and then plus sine of this angle, which is again 45 degree. I think I'm right. Yep. Okay, so this becomes what? This becomes 1 upon root 2 into 2, that's root 2. So this becomes root 2 times k lambda by r. This is E1. Now as far as the second segment is concerned, the second segment will produce two components of electric field. One component will be parallel to this rod and the other will be perpendicular. Okay, and to calculate the parallel and the perpendicular, the one of the angle will become 0, the other 45. So what we are going to get here is like in this direction we will have a k lambda by r root 2, and in this direction also we will have a k lambda by root 2r. Okay, because if I put a 0 here and the other is 45, so I'll get 1 upon root 2, and to calculate the parallel component we will use cos 45 and cos 0. So 1 minus, okay, just a minute guys, to write the parallel component. Okay guys, I think I need to correct it a bit. Let's spend some time on this. Okay, let's spend some time on this. So E2 perpendicular is this one. Okay, so this will be, for writing perpendicular component we use sine. Okay, so sine 0 and sine 45 will give us k lambda by root 2r, that is okay. And for writing the parallel components, okay, we use cos. So cos 0 and cos 45 will give me 1 minus 1 upon root 2. Okay, so this is E2 parallel. Okay, now if I talk about the third segment, so third segment will produce the same field as produced by the second one, only the directions will differ. So we will have a E3 perpendicular here which will get cancelled out, and we will have an E3 parallel here Okay, this was E2 parallel. Okay, so the value will be same. And finally this fourth one will produce an electric field in this direction. A semicircle produces a field of 2k lambda by r. Okay, and yeah, so 2k lambda by r. Okay, now notice that ultimately we are left with two of these. Okay, so two of these, and E1, and okay, E1 is this much. Okay, so let me do it here. So 2 times of this value, okay, k lambda by r, then 1 minus 1 upon root 2, okay, plus E1. E1 was root 2 k lambda by r, okay, minus 2 k lambda by r. So let's finish this calculation. Okay, so from here we are getting 2 k lambda by r minus 2. Okay, so this 1 will get cancelled with this. Okay, 2 k lambda by r. Okay, and then we will have 2 k lambda by r and root 2. Okay, so we are getting a 0 here. So the value of a should be 0. It's given 2 here. It is given 2 here. Let me see. सो इसका आंसर बच्चों 0 ही लग रहा है मुझे. यहाँ पे अगेन गलत गिवन है. एक टेस्ट के अंदर ही सही आया होगा, जो टेस्ट के अंदर है वो सही मार्क्स मिले होंगे. ठीक है, दिस हैज़ टू बी 0. चलो अब चलते हैं नेक्स्ट क्वेश्चन के ऊपर. अरे ये बड़ा क्यों हो जाता है. ठीक है, तो नेक्स्ट क्वेश्चन में ये करंट इन द रेजिस्टेंस आर हमको निकालना है. ठीक है, तो बच्चों देखो ये क्वेश्चन बहुत स्ट्रेट फॉरवर्ड सा है. इस क्वेश्चन के अंदर हो क्या रहा है, ये एक सर्किट है. ठीक है, और ये एक दूसरा सर्किट है. ठीक है, ये दो इंडिपेंडेंट सर्किट्स है जिनको हमने एक सिंगल वायर से कनेक्ट कर दिया है. ठीक है, ये सिंगल वायर है. तो ऐसे केस में इस वायर के अंदर कभी करंट नहीं आ सकता, क्योंकि अगर इस वायर के अंदर करंट है तो इसका ये मतलब हुआ कि एक सर्किट से चार्ज ड्रेन हो रहा है और वो दूसरे सर्किट में इकट्ठा होता जा रहा है. ऐसा नहीं होता. ठीक है, मतलब कि सस्टेन्ड करंट जब आती है तो किसी रीजन से चार्ज ड्रेन नहीं होता, किसी जगह पे चार्ज जगह डिपॉजिट नहीं होता. मतलब अगर ये इस ब्रांच में करंट हुआ और ये फ्लो करता रहा तो कुछ देर बाद इस सर्किट से चार्जेस बहुत कम हो चुके होंगे. मतलब चार्ज एक जगह से निकल के दूसरे में आ चुका होगा, जो नहीं होता इस तरह से. तो इसका आंसर होगा 0. और एक और तरीका इसको प्रूव करने का, तुम यहाँ पे करंट को I मान लो और तुम इस सर्किट के अंदर इस नोड के ऊपर नोड लॉ लगा के देख लो, तो तुम्हें अपने आप I = 0 मिल जाएगा. ठीक है, जैसे अगर मैं मान लेता हूँ कि यहाँ पे I1 करंट गई है. ठीक है, तो इसका मतलब है कि यहाँ पे जो करंट गई होगी ये I माइनस I1 गई होगी. और फिर अब तुम इस नोड पे आओगे तो यहाँ पे I माइनस I1 आएगी, यहाँ से I1 करंट आएगी. दोनों मिला के 0 हो जाने चाहिए, बिकॉज दोनों इनकमिंग करंट है. तो टोटल इनकमिंग करंट = 0, तो I = 0 आ गया. ठीक है, तो इस तरीके से ये प्रूव हो जाएगा. अब हम चलते हैं क्वेश्चन नंबर 14 के ऊपर. तो क्वेश्चन नंबर 14 में क्या दे रखा है. सॉरी गाइज, I'm sorry guys, I switched over to completely over to Hindi. So in this circuit I'll explain the question again guys. So in this question what is happening, there are two independent circuits and they are connected by a single wire. So whenever there is such a situation, what happens is that the current in that wire will be 0, because if there is a current in the wire, it means that charge is getting drained from one of the circuit and it is getting collected in the other circuit, which is not a way to get a sustained current. Okay, so therefore the current will be 0. We can verify this by writing node law at this equation also. If you try to write the node law, you will mathematically get I = 0. Okay, now we come to question number 14. After steady state is achieved, the resistor dissipates eta time energy stored in the inductor in one time constant. Okay, so the value of eta is, okay, so once the steady state is achieved, then the role of the inductor will become like, the inductor will simply behave as the connecting wire, and in that case the current flowing in the circuit, okay, that will be given by 10 by 2, so 5 ampere current would be flowing. And the amount of energy dissipated in the resistor in one time constant. So we are trying, let me use I only, I'll try to stick to symbols. So E by R, okay, this is the current, I square R, so this is the power multiplied by time constant will give me the energy dissipated in one time constant. Time constant is what, L by R. Okay, so this is equal to this is eta times the energy stored in the inductor. Okay, so eta times energy stored in inductor, it is given by half L I square. So in fact this I square gets cancelled. Okay, this L gets cancelled. Okay, this R gets cancelled. So the value of eta is 2. Okay, even without using any number, we can conclude that the value of eta will be 2. Okay, and then the final question of this test. The charge on 3 microfarad capacitors stored in steady state is this much. So guys, notice that this is not a Wheatstone bridge, rather it's a symmetric circuit with a point symmetry in it. Like from this point we go to this direction 12 microfarad, we go in the opposite direction 12 microfarad. So it has a point symmetry. So if I assume a 0 potential here, and if I assume 144 volt here, and if I assume V1 here, then the potential at this point would be 144 minus V1, because the sum of potentials which are images of each other should be equal to the VA plus VB, like potential at this point plus potential at this point. Okay, now you can write the total charge present at this node as 0. So we will write it as V1 minus 144 into 6. Okay, V1 minus 144 into 6 plus V1 minus 0, V1 minus 0 into 12 plus V1 minus 144 minus V1, okay, into 3 as 0. From here we are going to get the value of V1, and the question is asking us for charge on, okay, so this becomes how much? So 6 V1 and then 12, so 6 plus 12 18, and then 2 V1, so 6 again. So this is equals to what? 144 into 6, 144 into 6, and from here we are going to get 0 plus 144 into 3. Okay, 144 into 3. So we are getting V1 is equals to 144 into 9, 144 into 9 divided by 24. Okay, divided by 24. So I think this is 6 times. Okay, and 6, this is 54. Okay, so 54 volt is the potential difference. So across the 3 microfarad capacitor, the potential difference would be 54 minus, so 144 minus 54 is 90. Okay, so 54 minus 90 is 36. So 36 into 3 is the charge. Okay, so if I compare this with this, I get the value of eta as 3. So 3 would be the right answer to this question. Alright guys, so I hope you enjoyed this paper. Apart from the fact that you may have won scholarships using this test, I hope you enjoyed the questions also, and these questions taught you something. I'll come back with the solution of the next test after the next entrance test. Enjoy guys, take care, bye bye.
Hi everyone, I'm your master teacher chemistry. I'm Nidhi ma'am. So let us now discuss the chemistry portion of your Eklavya Entrance Test. Let me tell you one thing, as compared to physics and maths, this chemistry portion came like really easy, pretty basic, and conceptually, fundamentally, these are the questions that you are very much expected to know at this stage. And still, if you are not getting good marks in this chemistry portion of the test, that is really alarming, students. So just make sure you know the fundamentals, the basic of chemistry thoroughly, nicely. Let's quickly check the questions, right? So the very first question is from solution and colligative property, Raoult's law. The another form of Raoult's law where we use the mole fractions of in vapor phase of components of the solution. So I will say the pretty direct question. I hope you all know how to convert the basic equation of Raoult's law in terms of the mole fraction of the components in vapor phase by using Dalton's law of partial pressure. So let me quickly write for you all. So 1 by P total, the total vapor pressure, that is equal to the mole fraction of A, that is YA, in vapor phase, that is the vapor phase, because we are given in the question the vapor phase, right, plus YB upon P naught B. Everything is given to you guys, pure component A, the vapor pressure is given, pure component B, the vapor pressure is given, and also the mole fraction of A in the vapor phase is 0.4. That means YA is given, and the sum of mole fraction of all the components is unity. That means YB is 0.6. So all these values. So I am sure by putting the values you can get P total. That is what it is asking the question is asking. I hope you did this question correctly, guys. Yes, so you can check. Of course, you will get the answer as A after putting all the values in the equation, right? Let us quickly see the next question. Okay, so compare the wavelength of light absorbed. So I hope you all know more is the energy, lesser is the wavelength. E is inversely proportional to lambda, guys. So you are asked the wavelength order. So let me write. So delta E is inversely proportional to lambda. More is the CFC, more is the this energy difference. Lesser will be the wavelength absorbed, right? So we can see we have various complexes in which we have different ligands. So we just need to look the spectrochemical series and arrange these ligands according to their strength. From the spectrochemical series, I'm sure you all are aware that out of NO2, NH3, H2, NO2 negative, which is the strongest ligand, that is NO2. That will give you the maximum CFSC, right? The maximum energy difference. And then we have ammonia and water. H2 is a weak field ligand. So the strongest ligand NO2 negative followed by ammonia, and then we have water, which is a weak ligand. So you know the order of their splitting energies, so which is inversely proportional to wavelength. And I'm again very sure if you are conceptually fundamentally strong in coordination compound, you can easily crack this question, right? So indeed the answer to this question is A, because as I told you, delta E, the maximum energy is in NO2 negative, CFS is strongest field ligand, that means the wavelength is minimum. Whereas if water is the ligand, the weakest ligand, that means delta A is least, so lambda will be the maximum. So this will be the order R, Q and P. This is the order, right? Let's move on to the next question, guys. Next question, find the correct method to detect the following complexes, right? Pretty easy, I will say. I'm sure you know the ions outside the coordination sphere. You can ionize them, you can, break them into ions. So you have sulfate ion outside the coordination sphere of this complex, and you have bromide ion outside the coordination, complex of this coordination compound. And the options, pretty easy. Even if you see the very first option A, use AgNO3, you will clearly see if you add AgNO3, because this is bromide ion, which can be ionized, right? Bromide ion can be formed. So on adding AgNO3, you will get AgBr, right? The precipitates of AgBr, pale yellow precipitates of AgBr. By looking at those precipitates of AgBr, I'm sure you can detect, yes, which complex is having bromide ion outside the coordination sphere. Again, I'll see the easy question, right? Basic fundamental. So AgNO3 will form yellow precipitates of AgBr with the second complex, right? Let us quickly move on to the next question. In which of the following, right? The question is which of the following the reduction potential will be negative. The negative value of reduction potential, as you all can see, you have pressure of H2 and you have H positive, right? So you are just supposed to write the Nernst equation for hydrogen electrode. You can say, right? As you know, for hydrogen, the equation is 2H positive plus 2 electron gives H2. So this is the equation. Let me write the equation, guys. So I'm sure you know the equation for hydrogen electrode or hydrogen. This is gas. So you have to write the Nernst equation, and I'm sure you know E naught cell is 0 for hydrogen electrode. It is a standard hydrogen electrode. So we have E is equal to 0, that is E naught is 0 minus 0.059 over 2. The number of electron is 2, right? Log of pressure of H2, that is given in every equation, upon the concentration of H positive and raised to power 2. Now putting the values in this Nernst equation for pressure of hydrogen, the concentration of H positive, you can get where you are getting the negative answer, right? So just check by putting the value where you are getting the negative answer. In all these options, put the values. I'm clearly very much sure that you can figure out, right? the negative, because there is a negative, and of course you know log 1 is 0, and if you take the log of the values less than 1, it will be negative value. I'm sure you will get your answer correct, right guys? So again, the answer to that question is C, right? So put pressure of hydrogen 1 and H positive 2 square. It will be a square, so make sure that you do it correctly. You will get a negative value. Now, next question. In the following reaction, there is a reaction given to you. A gives B plus half C. The increase in pressure from 100 mm to 110 mm is observed in 5 minutes, right? There is an increase in pressure from 100 to 110, right? Calculate the rate of disappearance of A, of course, because A is getting converted into B and C in mm per minute. So let me write the reaction, guys. A gas is giving B gas plus half of C gas. Initially, I'll say the pressure is 100 mm. So I can say 0 or 0. So 100 minus x, it will be x and it will be x by 2. Now the total pressure after 5 minutes will be 110. That means 100 minus x plus x plus x by 2, right? That comes out to be 110. Yes, and that can give you the value of x. You can calculate x. How much x, like x, how much B is produced, how much C is produced, and how much x is utilized or disappeared in 5 minutes. So rate of disappearance, I'm sure you'll get how much A is utilized in 5 minutes, right? The change in concentration by time taken is 5 minutes. By solving this equation, you can get the value of x clearly, right guys? So you can see the solution here. Again, I'll say a pretty easy one. You can see here. So your x is coming out to be 20. So 20 by the change in concentration, 20. So 20 is the change in the pressure after 5 minutes, in 5 minutes for A. So 20 divided by time taken, that is the rate of disappearance in mm per minute. Right? Let us move on to the next question. The rate of radioactivity depends upon. So the radioactivity decay depends upon the number of unstable nuclei or the number of unstable particles in the substance. Right? I'm sure you all know, and not directly proportional. So guys, it is independent of pressure, temperature or physical state. It depends upon the number of unstable nuclei in the sample. So indeed our answer will be D donkey, none of these, right? Yes. So none of these is the answer for this question, guys. Let's move on to the next question. Yes. Which of the following statement is true for a mixture containing immiscible liquid? So if the liquids are immiscible, they cannot be mixed. That means the total pressure of the solution is the sum of the individual pressure of each liquid, right? So the P total will be PA plus B in case of immiscible liquids. So total pressure will be more than, of course, either of the component, the pressure of either of the component, because P total is PA plus PB simply, right? That means the boiling point, if the total pressure is more than any of the component, that means the boiling point of that mixture, right? That will be less than, because total pressure is more. More is the vapor pressure, lesser is the boiling point. I hope you remember. So total pressure of the mixture containing two immiscible liquid is the sum of the partial pressure, right? So that means P total will always be more than the pressure of either of the component. That means the boiling point of that mixture is less than that of the component liquid, right? So indeed our answer is C. If you know the relation between vapor pressure and boiling point, and if you know the total vapor pressure of a solution containing immiscible liquid, these basic conceptual things if you know, I'm sure you will get it right. Let's move on to the next question, guys. Okay, so again a question on colligative properties. Let's see the question. Which of the following solution has maximum boiling point? As you know, when we have a solution having non-volatile solute, there is elevation in boiling point, and the elevation in boiling point is a colligative property which depends upon the number of solute particles. It is a colligative property. So we are supposed to check in which there is a maximum boiling point, or the elevation in boiling point is maximum. The delta TB depends upon the number of particles, right? So let us see the question. Molarity of all the options are same. So we have K4FeCN6, we have glucose, we have AlCl3, we have NaCl. So let's see which will give the maximum number of particles in solution, because some of them will dissociate, they will break into ion in solution. So let's check, guys. So you know this is a coordination compound, it will give 4K positive plus FeCN6 4 negative. So you'll get, in total, you'll get 5 ions here, 5 particles per molecule. Glucose will not dissociate, right? AlCl3. Again, if it dissociate, it will give 4, and NaCl. Although AlCl3 is a covalent molecule, but that also the dissociation depends upon various factors. NaCl clearly a strong electrolyte, so Na positive and Cl negative. So the maximum number of particles, solute particles present in option A, that means, so the elevation in boiling point will be maximum, which is a colligative property in A, right, guys? So A is the answer. I'm sure you must have solved question based on the same. The answer indeed is A, right? Next question. So guys, what I'm going to tell you is, chemistry is not something in this paper which is tough, or you know, you're very much expected to get good marks in chemistry. Again, I'm letting you know, if you are not able to solve these questions or get most of them right, that clearly indicates you really need to work hard in your chemistry portion, because it is alarming at this stage, right? Okay, yellow color of a solution of Na2CrO4 changes to orange. Yellow to orange. Chromate to dichromate. Chromate is yellow, dichromate ion is orange, right? When CO2 is passed, so I have already told you the answer. Chromate is yellow, dichromate is orange. So indeed the answer is C, sodium dichromate. CO2 when it passes, so CO2 when combines with water, it forms carbonic acid. So the solution becomes acidic. Your chromate ion, it is not an I will say redox reaction, because chromate ion, in chromate and dichromate ion, both have chromium +6 oxidation state, right? Pretty fundamental question. Next question, let's solve the next question, guys. Okay, when KBr react with KMnO4 in alkaline medium, what is the product? So as you are already aware, in redox reaction, that depends upon, the product depends upon the medium we are taking, because the valency factor depends upon the medium. So when your KBr reacts with KMnO4, what will be the product form in alkaline medium, right? So KBr, when KBr reacts with KMnO4, that is MnO4 negative ion, I will like just take the ions in which there is a change in the oxidation state. I'm sure you all are aware, in alkaline medium, your permanganate ion, the oxidation state +2 in acidic medium, and if I talk about in alkaline medium, it will be +4, right? +4 is the oxidation state, and your Br negative ion will get converted to BrO3 negative, in which the bromine has +5 oxidation state. If it will be acidic, if the question is based on acidic, right? If there is acidic, that means the product will be Mn in +2 oxidation state. Valency factor of KMnO4 in acidic medium is 5, and bromine will be Br2, right? So because they asked us, we have to check the option, various option. You might not get alkaline here, right, in the paper. But of course, if you check the following option, the only possible correct option for the reaction of KBr and KMnO4 is BrO3 negative and MnO2. Because if it is acidic, product will be Br2 and Mn in +2 oxidation state, right? So indeed, the answer to this question is A, right? Happening in alkaline medium. Okay. Now the next question, which is an integer type question. when hydrated FeCl3 is heated, so FeCl3 hydrated salt is heated. This precisely the reactions are given in your JEE also, right? So if it is heated, what the products will form? I am not balancing it, guys. Ferric oxide plus HCl plus H2, right? And POAC, principle of atomic conservation. If you have 3 chlorine atom, of course you will get 3 HCl, right? 3 chlorine in the product side also. So indeed your answer will be 3. How many moles of HCl you will get after heating your hydrated FeCl3? That the answer is 3. Got it, guys? Yes. So if you are doing your inorganic chemistry, it is really recommended that you should definitely read the theory, some extra part other than NCERT from the books like JEE Sudarshan Guha, which are there for your JEE or JEE Advanced, right? JEE means in Advanced. Okay, let's move on to the next question, guys. Right? Okay, the next question we have is maximum oxidation state of iron is plus X. And I'm sure in your paper it will be like more clear to avoid any ambiguity that it should be an even number. X is an even number, which is the highest oxidation state of iron. I'm sure most of you know the stable oxidation states, the oxidation state in which iron exists is +2 and +3, right? So most of you are aware of this +2 and +3, right? But let me tell you guys, the compounds are also known in +6 oxidation state, right? So we do have compounds in +6 oxidation state of iron, like K2FeO4. There are compounds in which your iron exists in +6 oxidation state, which is even number. They are asking you the even highest oxidation state, the even number. The answer is +6. Maybe this is one of those questions most of you are not aware of. Most of you must be writing either +2 or something of that sort. But highest even number, the oxidation state, highest oxidation state is +6. So something to, get from the questions, chemistry questions, that you should remember if you are not aware of the oxidation state of iron. Okay, let's move on to the next. Calculate the pH of solution in hydrogen electrode in the following cell. pH of solution, right? So you have to calculate the pH of solution. So guys, what is the pH of solution? So pH, again you are supposed to write the Nernst equation. The question is given to you guys, you can see clearly. So we have 0.059, as you can see there, the change in electron is 2, right? So log of the concentration of Zn2 positive ions into the pressure of H2 and upon the concentration of H positive. So this is how you can write your Nernst equation. Guys, EMF is already given to you, right? EMF is already given to you. And indeed, and of course, E naught cell, I'm sure you got it right, you got it correctly. What the E naught of cell you are supposed to take here, guys? Yes. What is the E naught of cell? I am sure Nernst equation, otherwise there is nothing in this question left, right? So what you are supposed to take here? What is the E naught cell here that you are supposed to take? E cell is given to you, E naught cell, and the rest you are supposed to do. So EMF is given, that is 0.26, right? Yes. The concentration of Zn2 positive iron, pressure of H2 is given to you. The zinc is solid, of course, and H positive concentration, that is also given to you. I'm sure E naught cell is provided in the question that you can put here, right? All the things are given other than H positive, right? Only H positive. By putting the values in Nernst equation, you can get the value of H positive, the concentration of H positive ion after solving this equation. Once you get this after solving you get this concentration of H positive, and this is all what you need to calculate pH. pH is minus log of H positive ion, right? So pH is minus log of H positive, and H positive you can get by solving this Nernst's equation, right guys? Yes. Okay, let's move on to the next question. Now again a Nernst equation based question you had here. Let's move on to the next question. The mole fraction of urea in aqueous solution of urea is 6% W by W, right? And that mole fraction is x into 10 to the power minus 4. Calculate the value of x. I'm sure you all know what the urea is, the very first organic compound synthesized in lab. What does this mean? 6% W by W. That means 6 grams of urea is present in 100 gram of the solution. Right? If you take 100 gram of solution, your 6 gram is urea. Rest 94 gram is water, because it is an aqueous solution, which is already mentioned here. And you are supposed to calculate the mole fraction of urea. So pretty simple. Moles of urea divided by moles of urea plus moles of water, right? Moles of water you can easily calculate because you know the mass of urea and water. Given masses are there: 6 gram urea, 94 gram water, and molar mass of urea and water I'm sure you are aware of. So you can solve, you can put the values, right? So moles of urea 6 by 60, given mass is 6, molar mass is 60. The moles of water in the solution, of course, 94 divided by 18, and your answer will come out to be 0.0188 after solving. But you are supposed to express in this notation, and you have to tell what is x. Of course, that will come out to be 188, right? Let's move on to the next question, guys. Okay, calculate the number of isomers of this complex. Platinum complex, you know platinum in coordination number 4. The complexes are square planar. If they are square planar complexes, you have ammonia, you have thiocyanate ion, and which can also be isothiocyanate because of the difference in the linkage, whether it is the CMA is linked with nitrogen or the donor atom is sulfur. So we can have thiocyanate or isothiocyanate, and it is a square planar complex. So cis and trans geometrical isomerism is there because it is a square planar complex, platinum complexes. So guys, you can see here you have two NH3 ligands and you have SCN. Please take SCN. One can be cyanate, one can be isocyanate. Both can be thiocyanate and isothiocyanate. Both can be thiocyanate and both can be isothiocyanate. So taking all the probabilities and considering geometrical isomerism, cis trans in each case, we can get total number of isomer, that is 6. 2, 1 cis 1 trans if both are, you can say, thiocyanate. 2 if both are isothiocyanate, and 2 1 cis 1 trans if one is thiocyanate and another is isothiocyanate. So the total is, of course, we have the answer as 6. So this is all for your the chemistry part in the paper, guys, right? So done with the questions. I hope you really scored high in the chemistry portion, and if you are not scoring good in this chemistry portion, please make sure your fundamentals, your concepts are clear in chemistry, right? So till then, bye, take care, God bless you all. Keep learning, keep growing.
Hello everyone, I am Surendra Jain, Master Teacher of Maths in Vedantu. I am discussing Eklavya Entrance Test-1 which was conducted recently, and this is question number 1, in which we are given A and B two matrices. Determinant of A as 6 and we have to find determinant of adjoint of B. Now because B is 3 into 3 order, so there is a property we can write determinant of adjoint of B as determinant of B whole square. The property is power n minus 1. So here it will be square. Now to find determinant of B, Okay, we have to use some properties so that we can convert determinant of B in terms of determinant of A. So for that, what I will do, determinant of B, okay, I will write this as some property I'll use, and the first property that I'm going to use is that I will change R1 as R1 plus R2 plus R3. Okay, by doing this you can see my first element here will be 2 times P plus 2 times X plus 2 times A. Here it will be 2Q plus 2B plus 2Q plus 2B plus 2Y, and here it will be 2R plus 2C plus 2Z. We can take 2 common, so it will become P plus X plus A, and here it will be Q plus Y plus B, and here it will be R plus Z plus C. Okay, so these are the first these are the elements of first row. Second row, third row I am not changing, so it will be A plus X, B plus Y, and C plus Z. Similarly, A plus P, Q, B plus Q, and C plus R. Next property which I am going to use is that I will change R2 by R2 minus R1 and R3 by R3 minus R1. By doing this, what we will get? We will get second row as the element will be here minus P, minus Q, and minus R. Here it will be minus X, minus Y, and minus Z. The first element will be same, P plus X plus A. First row elements will be same here also and here also. Okay, now what we can do next is we can add new row 2 and row 3 getting added to R1. Means I will be writing R1 as R1 plus R2 plus R3, and by doing this we will be getting first row elements as, I think P and X will get cancelled, so we will be having only A here. Likewise we will be having B here, and we will be having C here. Now from these two rows, if I take minus sign common, so 2 minus sign means nothing, or plus sign you can say. So here it will be P, Q, R, and this will be X, Y, and Z. And this is nothing but same as determinant of A. So it will become 2 times 6. That means it will be 12. Okay, and we are supposed to find determinant of B square, so it will be equal to 144. So the answer of this question is D. Okay, I think question was not difficult. If you have done questions in determinant, you must have done this question also, where B, determinant of B becomes 2 times determinant of A. So if you remember such question, I think then this question is even easier for you. Okay, moving to the next question. Okay, next question is, if the system of linear equations has non-zero solutions x, y, z, then we have to find x, z upon y square plus k is equal to. Okay, now we are given homogeneous system of linear equations, and if it is having non-zero solution, this means this determinant made by the coefficient should be equal to 0. That means it should be it should be first element 1, then k, then 6, then 3, then k, then minus 4, then 2, then 4, then minus 6. Now we can use some properties, or without properties also I think it can be done. Okay, let us use some property. Maybe I can use the property that R2 changed by R2 minus 3 times R1. So this element will become 0, and similarly R3 is changed by R3 minus 2 times R1. So this element at the place of 2 becomes 0. So here we will be having 1, k, 6, no change in row 1. Row 2 will be 0 here, and I think minus 2k here, and minus 22 here, because 3 times 6 is 18. So minus 4 minus 18 is minus 22. Here it is 0. This will be 4 minus 2k, and that will be minus 18. And that should be equal to 0. If I expand along column 1, if we expand along column 1, we will be getting 18 into 2, 36 times k, minus minus plus I can write. Actually it will not be 44, it should be 22 into 4 minus 2k equal to 0. Okay, the remaining calculation I will do here. So we can see 36k and minus 44k, it will be minus 8k, and plus 88 equal to 0. So from this we get the value of k to be equal to 11. Now once we know for k equal to 11 determinant is 0, this is going to have infinite solutions, including 0 solutions also and non-zero solutions also. Now I'll put k equal to 11 and I will write just first two linear equations as x plus 11y equal to minus 6z, and second equation is 3x plus 11y equal to 4z. Now these two equations I have taken as linear equation in x and y and taken z as a constant on the other side. We can solve it. We will get x and y in terms of z. If you subtract this first one from the second one, we will be getting 2x equal to 10z, which gives x equal to 5z. And if you put x as 5z here, I think we will be getting y is equal to minus z. Okay, we can put these values and we can verify that it satisfies third equation also. Okay, now what we are looking for is this xz upon y square. So if I put x as 5z and y as minus z, I think it will become 5 plus 11, so that is equal to 16. So my final answer here should be 16. So answer is D here. I think this is also one standard problem based on linear equations or homogeneous equations where you have to use the determinant. Okay, so that is how this is done. Now moving to the next question, the question number 3. It is from functions. It says gx is equal to 1 minus 2 times x plus 2 times greatest integer function, and fx is given as this. Then we have to find for all x the range of f of gx. Okay, first of all we have to understand this gx here is here gx here is 1 minus 2 common x minus greatest integer x, and if you remember, this x minus greatest integer function is nothing but fractional part function. So 1 minus 2 times fractional part function. The range of fractional part function for real numbers is from 0 to 1, where open bracket on 1 and closed bracket on 0. So if we put these values of fractional part here, I think gx will belong to, I think if it is 0 then it will be 1, when it is 1 then it will be minus 1. So open bracket at minus 1 and closed bracket at 1. Okay, now we have to find the range of f of gx. Okay, how to find this? I think here you just have to check whether this gx can take negative, positive and 0 values or not, because this function is just telling you if x is negative then it is minus 1, if x is 0 then it is 0, and if x is positive then it is 1. Now you can see that gx is taking all sort of values, positive also, negative also and 0 also, because it will be from minus 1 to 1, where in between 0 will also lie. So for this f of gx, the range, final range would be, will be having all elements, they are minus 1, 0 and 1. So answer for this question should be C. I think that was easy question. You just have to figure out that x minus this greatest integer function is fractional part function, and then what is the range of gx, that will make sure the answer of this question. Okay, now moving to the next question, we are given question number 4 here. A and B are two sets containing 4 and 2 elements respectively. Then number of relations from set A to B, each having at least 3 elements, we have to find out. Okay, so first of all you should remember that any relation from A to B is a subset of A into B, or you can say Cartesian product A into B. And because A is having 4 element and B is having 2 elements, that means number of elements in A into B, that is their Cartesian product, will be 8. 4 into 2, 8. Now if relation is a subset of A into B, so total relation could be 2 raised to the power 8, that is I think 256. But these all relations will include those subsets also which are having no element in it, or one element in it, or two element in it. But we are looking for those relations from A to B which are having at least 3 elements. Okay, so we have to we have to subtract how much? Those subsets of A into B which are having 0 elements, which is actually 8C0, which are having 1 elements, which is 8C1, and then 8C2 for those subsets which are having 2 elements in it. So 8C0, 8C1 and 8C2 we have to subtract, and I think it becomes equal to 1 plus 8 plus 28, and that we have to subtract from 256. So answer here should be equal to, I think 256 minus 28 is 228, minus 8 220, minus 1, so it will be 219. So that is the answer of this question. Once again, easy question. If you know what relation is, okay, you know how subsets, number of subsets can be found, so then I think this question is easy. Moving to the next question, we are given ABC belongs to real and fx is a quadratic such that f1 is equal to 3, and f of x plus y is equal to fx plus fy plus 2xy for all xy belongs to R. Then we have to find the summation n is equal to 1 to 10 fn. Here we are given fx as a quadratic, so if I put this quadratic expression in this given expression, we can write this as a into x plus y whole square plus b into x plus y plus c, and that will be equal to ax square plus bx plus c, that is 1 fx, plus ay square plus by plus c, that is for fy, plus 2 times xy, 2 times xy. Now you can easily see, if you open it, I think bx by will get cancelled. In fact, if you open this bracket, this ax square term and ay square terms will also get cancelled. On the left hand side, we will be left with 2axy, and 1c is also cancelled. So on the left hand side, it is just 2axy, whereas on the right hand side, because this ax square, ay square is also getting cancelled, so we are having only c and 2xy. Now this relation should be valid for all xy belongs to R. So this is possible only if the like coefficients are equal on both sides. So this 2a should be equal to 2 and this c should be equal to 0. So if we get value of a to be 1 and c to be equal to 0. And also we are given f1 to be 3. f1 means a plus b plus c, because if you put x as 1, so a plus b plus c, and that is equal to 3. A is 1, c is 0, so the value of b will be equal to 3 here. Not 3, it will be equal to 2. The value of b will be equal to 2. Okay, now we know the quadratic, we just have to find this summation. Now to do this thing, what we can do, first of all, let me write what my fx is. Fx is x square plus 2x. Okay, you may also write it as x plus 1 whole square minus 1. Okay, now if we have to do this summation, this s or summation, I think for putting n is equal to 1, we will be getting 2 square. Okay, if we put n is equal to 2, we will be getting 3 square minus 1 and so on. And if we keep on doing this, when n is equal to 10, it will be 11 square minus 1. Okay, so we can use the formula that we study in sequence and series chapter. We can write it as summation n square, where n starts from 1 to 11. I have taken one extra term here so that we start from 1 only, 1 square, 2 square till 11 square. So I will subtract 1 for that, and also these 1 1 1, you can see they are 10 times, so that minus 10 will also happen here. Okay, you just have to find this. So sigma n square will be 11 into 12 n plus 1 into 2n plus 1. 2n plus 1 means I think 23 upon 6 minus 11. That is what we need to do. Okay, now this 6 will cancel 12 2 times. Okay, you can take 11 common. You can take 11 common. Let me do this calculation here. You take 11 common, and then it will be 46 minus 1, that is 45. 45 into 11, I think it will be 495. 11 into 45 is 495. So answer for this question should be C. Okay, I think it's also easy question, I will say, not very difficult, but you should know these calculation, and then you have to use this formula sigma n square. You might have done without this also, where only sigma n square and sigma n will be used, and then also you will get the same answer. You can check, maybe you might have done that way also, some of you. Moving to the next question. Yeah, moving to the next question, that is question number 6. Let me check. Yeah, question number 6. It says S is equal to T belongs to R such that fx equal to mod x minus pi into e power mod x minus 1 into sin x. I think here there should be a bracket. I think here it should be bracket. Okay, is not differentiable at t. Oh no, that bracket is already there. Sorry, bracket is already there. And then we have to find the set S is equal to. Okay, now to do this question, first of all we should understand that differentiability comes because of mod sign. Wherever mod is opened with different signs, that for greater than pi it will be plus sign plus x minus pi, for less than pi it will be minus of x minus pi. So the mod, wherever it changes sign or expression inside it changes sign, there is a chances that function is not differentiable. Otherwise I think every function used here, like sine function, exponential function or linear function, they all are differentiable. So if the mod sign was not there, it would have been totally differentiable. So the only points where we should doubt is, one is pi, where mod of x minus pi will change its sign, and another will be x is equal to 0, where mod x, which is on the power of e, will change sign. So only at x is equal to pi and 0, differentiability is to be checked. Okay, now I will tell you one direct method. Please listen carefully. At x is equal to pi, I think this will become 0, and x is equal to pi, sin x is also becoming 0. And because of this, because sin x is 0 and this is 0, that means x is equal to pi is a double root, repeated root. Okay, so if it's a repeated root, its a derivative at pi has to become equal to 0, whether you take it from LHL, from left hand side or from right hand side, it will be 0. And I'll tell you why it is happening so, but let me first complete this question. At x is equal to 0, you can see this bracket is becoming 0 and sin x is also becoming 0. So this 0 is also a repeated root, which means this because of repeated root, the derivative at 0 will again be 0 only, whether you take from left hand side or from right hand side. Hence this function is going to be differentiable everywhere. So the answer should be C. Now I will tell you why on both sides derivative is going to be 0. Please see for pi first. Okay, at x is equal to pi, if I check, or maybe pi minus or pi plus, you may take anything. So the derivative would be f of pi plus h minus f of pi upon h, where h tends to 0. Okay, now pi plus h, here it would be limit h approaches to 0, this would be pi, this would be h only, and then e power, this bracket I can write it directly e power pi only, because pi plus h, as h tends to 0, is pi only, and minus 1, and this bracket is not 0. Okay, so we can write directly h as 0 in between here, and then sin h, because sin pi plus h is minus sin h actually, so minus sign will be there. It will be minus sin h whole divided by h. Now you can see this h is getting cancelled, and because h approaching to 0, sin h will be 0, so you can see it will be equal to 0. Now you can see why this double root made sure that this will be equal to 0, because of this double root, one h is coming here, okay, and one h or maybe sin h is coming here. So two things are becoming 0 at h approaching to 0, whereas in the denominator we have just one h. So this h will cancel here, but still one 0 will be there. And likewise you can check for x is equal to pi minus also, I will not do it, that derivative will be 0. So both side derivatives are 0 0, and hence this function is differentiable at x is equal to pi. If sin x was not there, then you can check this will be non-differentiable, because then at x is equal to pi you are not having repeated root, only one root is because of this x minus pi. Okay, now similar to this, let us do for 0 also. Suppose I have to do for x is equal to 0 plus. Okay, then what will be the derivative? I think fh minus f0 upon h. Okay, at 0 the value of function is 0 because sin 0 is 0, and also e power 0 minus 1 is 0. So what will be this thing? It will be fh, means it will be pi minus h here after opening this mod, and then e raised to the power h minus 1 into sin h whole divided by h. Now sin h upon h is 1, sin h upon h is 1, e power h minus 1 will also be 0, so hence this entire thing becomes pi into 0 into 1. So you can check that right hand derivative is coming out to be 0 here. Similar to this, you can check for x approaches to 0 minus also, that it will be equal to 0. Okay, hence both derivative, left hand derivative, right hand derivatives are 0 0, and hence function is differentiable at 0 also. So there is no point where function is non-differentiable, so answer is 5. Okay, now moving to the next question, question number 7. Question number 7, actually, 1 minute. Yeah, this was 6 which we have done. Now coming to the question number 7, it says the graph of function f contain the point p and q. The equation of secant line through p and q is given by this equation. Then we have to find f dash minus 1. Please understand what this question is. You are having, let's say, this kind of graph of this function f, where these are 2 points, where this is p minus 1 comma 2 and this is q s comma r. Okay, we are given the equation of the line pq, y is equal to mx plus c form. Okay, where this thing is actually the slope of line ps is equal to p, not ps, it is ps square. Slope is p, slope of pq, and that is given as s square minus 2s minus 3 upon s plus 1. Now listen carefully. As you know the geometrical meaning of derivative, that as this q approaches to p, means s approaches to minus 1. Okay, this secant will become tangent at p. Okay, and then this slope as s approaches to minus 1 will give you the tangent, will give you the slope of tangent at p, which is nothing but f dash minus 1, dy upon dx you can say, or f dash minus 1. So f dash minus 1 is actually equal to limit s approaches to minus 1 and this slope pq, slope of pq. Now we have to find the limit of this, we have to find the limit of this expression, which is s. I think we can make the factor also. It is s plus 1 and s minus 3. You can check s plus 1, s minus 3 upon s plus 1. So s plus 1 is getting cancelled, so we are getting minus 4 as the answer. Again, bacho, question was not difficult. You just have to understand that how to find f dash minus 1 from the secant line. You have to look at the slope, and putting s approaching to minus 1 will give you the answer. So answer here would be B. Okay, now moving to the next question. Question number 8. We are given the question says the acute angle between normals to the graph of function fx at points where graph cuts y-axis and the graph cuts the x-axis at a point nearer to the origin. Let us see what this graph is. I think very easy integration, you can do it. I think we can do the integration and we can find fx. It will be equal to t square minus 5t and putting limit 2 to x. If you put both limits at t square, it will be x square minus 4, and if you put both limits to this 5t, it will be x minus 2. So this becomes x square minus 5x and I think plus 6. Okay, so this is nothing but a quadratic. I think its roots are also very easy, and the graph will be something like this. The roots are 2 and 3, and y-axis will be intersecting the graph here at 0, 6. So let us read the question once again. It says the acute angle between the normals to the graph of function at the point where graph cut the y-axis. So we have to find the normal at 0, 6, something like this, and at the point where graph cuts the y-axis and the graph cuts the x-axis nearer to the origin. I think there are 2 points where graph is cutting x-axis. One is 2, 0, one is 3, 0, but we are looking for the point which is nearer. So it will be 2, 0. So here also there will be a normal, and we have to find this angle theta. Okay, so what we need to do, we need to find the slope of normal at 0, 6 and 2, and then I think we are done. And to find the slope of normal, I think we need to find f dash x. F dash x can be found directly from this relation also using Newton formula, Newton-Leibniz formula. It will be 2x minus 5. Or you can do the differentiation of this quadratic also, that is also giving you the same thing. Now f dash when it is cutting y-axis, the value of x is 0, so f dash 0 is minus 5 and f dash 2 is equal to I think minus 1. So from that you can see the slope of normal 1, that is at 0, 6 will be equal to 1 upon 5, minus 1 upon f dash, and slope of normal 2 will be equal to 1. Now using this we can find the angle between two tangents, or two normals actually, and that is tan theta equal to m1 minus m2. So you can write 1 minus 1 upon 5 upon 1 plus m1 into m2, that is 1 upon 5 only, and if you simplify it, I think it comes out to be 4 upon 6, that is 2 upon 3. So the acute angle between the normals has to be tan inverse 2 by 3, that is given in option number D. Okay, again question not much difficult. You have to find the function, you have to see which points, then dy upon dx, then slopes, and using slopes tan theta. There are series of things, but if you are okay with these all concepts, I think question is not difficult. Okay, now moving to the next question. Question number this was 9. In this question number 9, we are given fx equal to x square ax plus b and c for various interval of x, and we are given that fx satisfies all the conditions of LMVT, Lagrange's mean value theorem, in closed interval 0, 2, and p is a point on the curve fx in 0, 2 where tangent is parallel to the chord joining the end points at x is equal to 0 and x is equal to 2. Then we have to find the value of a plus b plus c plus 4d. Now first of all, because fx satisfies the conditions of LMVT, means it should be continuous, it should be differentiable. I think these parts are not difficult. Let me do the calculation here. Okay, for continuity at x equal to 1, okay, I think left hand limit and value is 1, right hand limit is a plus b, so that is one equation. Okay, now continuity at x is equal to 2, continuity at x is equal to 2, left hand limit will be given by I think 2a plus b, and that will be equal to c. So we are having these two equations, a plus b equal to 1 and 2a plus b equal to c. Okay, now moving to the condition on differentiability. Okay, for differentiability, for at x is equal to 1, I think left hand derivative will be given by differentiation of x square, that is 2x, and putting x is equal to 1, I think we will get 2. Whereas on the right hand side, derivative is just a, so this gives you the value of a as 2. Okay, so the value of a as 2, then I think from these equation 1 and equation number 2, we will get b to be equal to, I think, minus 1, and you can get value of c as 4 minus 1, that is 3. So these are the values of ABC that we are getting. Okay, derivative at 2 is not required to be found because we can only find left hand derivative because we are not having any information on right hand side of 2. Okay, and from 1 to 2 it's a linear function, so its derivative will be a only. At just one point x is equal to 2, if it is c, and if I make c such that the value at 2 and limit at 2 they both are same, then I think it is automatically ensured that it will be left, its left derivative is equal to the the derivative of ax plus b in the interval 1 to 2. I hope you are getting what I am saying, because from 1 to 2 you can see it's a linear equation. Okay, and if my c is also equal to the limit, that is limit at x equal to 2 minus, then it's a complete linear function from 1 to 2 including 2 also. So left derivative at 2 will be same as derivative of this linear function in the interval 1 to 2. So that means it will be differentiable, there is no need to check, and in fact we have found already our constant a, b, c. Okay, now we have to find d also. And what is d? They are saying that this will be a function something like that, 0 to 1 it is x square, then it's a straight line something like this, there is no corner, there is no gap here, and then c. Okay, now they are saying that p d comma fd is the point on the curve in 0 to 2 where tangent is parallel to the chord joining the endpoints, that is at x is equal to 0 to x is equal to 2. Okay, so if I join this 2 with this 0, okay, that's a chord, and then there will be a point somewhere here which will be having tangent parallel to this thing. In my diagram it is not seen clearly, but these two are parallel actually, this chord or secant you can say, and tangent at this point is parallel. Let me make it again. What I am saying here is that this is my graph. Okay, joining these endpoints will give you secant, and there will be a point somewhere here where tangent will be parallel to this secant. Now I think it is fine, and we have to find this d. Now how to find this? First of all, the endpoints are 0, 0, and this point is I think 2, c value is 3. Okay, so the slope of secant will be 3 upon 2 only. Now I have to find a point d or p, actually d comma fd, where slope should be equal to 3 by 2. Now to do this thing, what I will do, I will take the derivative of this function fx, and you can see it is equal to 2x for 0 to 1 interval, and it is a whose value we have found 2 between 1 to 2. This is when x is from 1 to 2, and this is when x is from 0 to 1. So you can see between 1 to 2 it is 2, so it cannot be equal to 3 by 2. So the only option that we are left with is it can be in the interval 0 to 1. So I need to put this 2x to be equal to 3 by 2, which gives you the required value of x, or you can say d, equal to 3 by 4. So hence this value required d is 3 by 4. So let me write d here. Let me write this as d equal to 3 by 4 here. C was 3. Okay, so a plus b plus c plus 4d is how much? A is 2, b is minus 1. So 3 plus 2, 5 minus 1, 4, 4 plus 3, 7. So I think answer of this question should be D. Okay, I think it is again very simple question I will say, but it tests every aspect of LMVT or related to that thing, that you know the condition of LMVT or not, and you can find that point C, f dash C, which is having slope of tangent equal to slope of secant. So this was based on the fundamentals of LMVT. I think nothing very difficult about this question, but yes, there are again some calculations involved. So again 2-3 minutes you may take in this question. Now moving to the next question, that is question number 10. We are given alpha beta belongs to R such that fx is equal to this x square into sine bx upon alpha x minus tan x for x not equal to 0, and f0 is equal to 1, and fx is continuous at x is equal to 0. Then we have to find 6 times alpha plus beta. Very simple question, macho. We have to find the limit so that it is continuous, means the limit should be equal to 1. Okay, so limit here would be limit here would be limit x approaches to 0, and this will be x square sine beta x. You can divide by beta x, and you can multiply by beta x here, and this a, this is not a, this is actually alpha x minus tan x. This we know is 1, we can put it 1 here. So this is actually equal to limit x approaches to 0 and beta x cube upon alpha x minus tan x. Okay, now you can use LH rule, L hospital rule, you can use expansion, okay, to solve this further. I think already it is 0.05. So if I use L hospital rule, LH rule, then it will become 3 times beta x square in the numerator upon alpha minus secant square x in the denominator, because we want this limit to be equal to 1 so that function becomes continuous. So because if it is 0 in the numerator, it should have 0 form in the denominator also, then only you can expect to have limit 1. Otherwise, if numerator is 0, denominator is non-zero, then this limit will be equal to 0. Okay, so here to make sure that limit is 1, I think your denominator at this step should be equal to 0, which means alpha will be equal to 1. Because at x equal to 0, secant 0 is 1. So if alpha is 1, then I think it is again 0.0 form. So I can use L hospital rule once again, LH rule, L'Hopital rule actually. X approaches to 0. It will be 6 beta x upon 1, differentiation will be 0, then minus 2 secant x into secant x tan x. So that means it will be secant square x and into tan x here. Okay, now x upon tan x is 1, x upon tan x limit is 1, and for remaining thing I can put x is equal to 0, secant 0 is 1, so it will be equal to minus 3 beta after simplification, and this is equal to 1. Okay, we have found alpha to be 1, we have found 3 beta to be equal to minus 1, and we are looking for mod of 6 alpha plus beta. So it will be 6 alpha plus 6 beta. 6 alpha is 6, 6 beta will be minus 2, hence answer will be 4. I think mod was not required, but maybe to confuse you, you are given mod, that you understand that it is negative, then only mod should be there, but this 6 alpha plus 6 beta is already positive, so answer is D. Okay, now moving to the next question, bacho, that is 11th question. Let me take the pen once again. Yeah, we have to find the minimum value of this expression x minus 4 cube plus x minus 10 cube, and mod is also applied separately. Now please understand, if we open this function as for different values of x, and I can remove the mod, I think it will be for x less than 4, they both x minus 4 and x minus 10 will be negative, so it will become 4 minus x whole cube here plus 10 minus x whole cube here. Okay, and between 10 to 4, maybe equal to sign can be put here, this x minus 4 whole cube will be positive, so we will write it like x minus 4 whole cube, and when x is less than 10 we will write this as 10 minus x whole cube, because 10 minus x is positive. And when x is greater than 10, they both will be x minus 4 whole cube plus x minus 10 whole cube, because they both are positive, so mod will be removed directly. Okay, now we have to find the minimum value. Minimum value is found when we find derivative to be 0 or we find derivative does not exist. Minimum or maximum are found at the critical point. Critical points are where the function is having derivative equal to 0 or derivative does not exist. Okay, so let us say this is my fx. Now if I find f dash x here, the first thing would be 3 times 4 minus x whole square, and there will be minus sign here. Similarly, minus sign will be here also. 3 into 10 minus x whole square. That is for x less than 4. So you can see for x less than 4, this derivative is going to be entirely negative. Entirely negative. Similarly, when x is between 10 and 4, between 10 and 4, it will be 3 times x minus 4 whole square and minus 3 times 10 minus x whole square. Here seems like derivative can be positive or negative also. In fact, this can be equal to 0, and there we can expect a point of minima. Likewise, for x greater than 10, you can check it will be 3 times x minus 4 whole square plus 3 times x minus 10 whole square. So again, the function is having derivative to be positive. 3 times x minus 4 whole square. Okay, so derivative is throughout positive for x greater than 10, negative for x less than 4, and between 4 and 10, if you try to make this equal to 0, let us try to solve it for equal to 0. I think 3 is common, so I can write it directly. X minus 4 whole square equal to it will be 10 minus x whole square. Open the brackets, x square term will cancel. In fact, you can write directly also x minus 4 is equal to 10 minus x, because for otherwise x minus 10, x will get cancelled and you will get no solution. Here x will be equal to 7, you can check. So it looks like there is just one point where derivative will be positive, where derivative will be equal to 0, and that is the probable point of minima. One more thing, for 4, if you check here, and I think at 4 the derivative here would be minus 3 into 6 square, and derivative from this thing will be equal to minus 3 into 6 square. That means they both are giving you same derivative. That means left derivative at 4 and right derivative at 4, they both will be equal. So maybe I can put equal to sign also here. Why I am doing this thing, let me tell you. Whenever there is a mod sign, you should always be skeptical whether function is differentiable or not. So if you are doing this differentiation directly, then you should first check the derivative at these end points, and then only you should put equal to sign. Here you can check at 4 the derivative was negative. Similarly at 10 you can check derivative here is positive and here is also positive, and they are same. Okay, now I think we are in position to conclude that before 4 function is decreasing, between 4 and 10 in the beginning it is decreasing, then it becomes increasing, and after 10 again it is increasing. So there is only one point of minima, that is 7, and there we will find the minimum value. So if you put x is equal to 7, that means it will be 3 cube here and 3 cube here. So answer will be equal to 54. So that is the solution of this question. Let me see what is the answer they have given. Yeah, 54. And same way I think it is done. Okay, now moving to the next question. Question number 12. It says find the square of distance between points on the curve whose distance from the line is minimum and maximum respectively. Okay, now I think this curve is very familiar curve, and it is actually ellipse. X square upon 6 plus y square upon 3 equal to 1, something like this. Okay, and we have to find point on this curve which are at maximum and minimum distance. Now this line is somewhere here, x plus y equal to 6, you can check. Now the point which is nearest to this line and lying on the ellipse should be something like the point where tangent will be parallel to this line, and farthest point will be the point where tangent will again be parallel to this line, but it will be lying on the other part of the ellipse. So these 2 points where tangents are parallel to this given line will be nearest to this line and farthest to this line. So we can find these points and we will get the then we will get the distance between these 2 points, and square of that distance will be the answer. I think that is what we are given in this question. Okay, now how to find these points P and Q, let us say. Okay, what we can do, we can take that parametric form of the ellipse. I think any point can be taken as root 6 cos theta comma root 3 sin theta, and equation of tangent on this ellipse using t equal to 0 will be x cos theta upon root 6 plus y sin theta upon root 3 equal to 0, equal to 1 actually, equal to 1. Now we want this tangent to be parallel to this line whose equation is x plus y equal to 7. Okay, that means if they are parallel, the coefficients of x and y should be in same ratio, or you can say the slope here is -1. Okay, so slope here also should be -1. So slope here would be minus cos theta upon sin theta, and I think root 3 upon root 6, and that will be equal to -1. From this we get cot theta to be equal to, I think this root 3 will cancel root 6 root 2 times, so yeah, root 2, and from this we will be getting cos theta equal to this cot theta is root 2, so cos theta will be equal to root 2 upon 3. I think cot theta is base upon perpendicular, yeah, so it will root 2 upon 3, and sin theta will be equal to root 1 upon 3. Okay, but cot theta is positive, then cos theta sin theta should be of same sign. They both can be positive or they can be both negative also. So you will get 2 points according to that. My P point can be found using cos theta and sin theta from this into this. Okay, so if I take positive values, okay, root 2 by 3 and root 1 by 3, then this will be, I think, a 2 comma 1 here, and if you take minus minus, then I think this will be -2 comma -1. Okay, so P point will be 2 comma 1 and Q point will be 2 comma -1, and we have to find the distance, in fact square of distance between these two. So PQ square will be equal to 4 square plus 4 square plus 2 square, that is equal to 20. So answer for this question is 20. Again, simple question, you just have to use the concept of tangency, concept how to find point at nearest distance or farthest distance using condition of tangent. Okay, and then you get the points and find the distance, that's it. Okay, now moving to the next question, that is question number 13. I think it's a very simple question. Please see, we are given delta 1 as this and delta 2 as this, then we have to find delta 1 upon delta 2. Now dear all, this delta 1, you can see it is nothing but if I take 2 common from first column and 4 common from the second column, then it's a standard determinant that you may remember it. It is P minus Q into Q minus R into R minus P. That is something that we expect that you remember it, or if you don't, then you can open it by subtracting row 1 from 2 and 3, so that you will get 2 zeros, and then you can open and you will get same thing. So delta 1 will be this thing. Now coming to delta 2. Now how to find delta 2? Okay, now there can be one method of factor theorem. Now you can check, if I put P equal to Q, if you put P equal to Q, you can see that second row and third row, they will become identical. If I put P equal to Q, then your R2, please check, and R3, they become identical. P, R, and here also P plus R, P plus R. So second row, third row will become same if P is equal to Q. So can I say that P minus Q will be one factor? Definitely we can say. Likewise, we can say Q minus R will be one factor, and likewise R minus P will be a factor. Okay, now if you open it directly, you can check. Suppose you expand along column 1, you can see the maximum degree of terms. Like if I open just first term, it will be PQ into Q plus R minus R plus P. Okay, so you can see that degree here is at max 3, and we have found 3 factors, which means we have found everything as far as factors are concerned, but there can be some constant here. Okay, and we need to find this constant, and then I think this question is done. Now to find these constant, what we do, we take some special values of P, Q and R. Maybe P can be taken as 1, Q as minus 1 and R equal to 0, because this determinant will be equal to this expression for all values of P, Q, R, because it's kind of identity. So putting any particular value will also give you the same value of K. So this determinant will become equal to, if you put P as 1, Q as minus 1, so this is minus 1 here, and I think remaining 2 will be 0, 0 here. Okay, P plus Q will be 0 here, P plus Q will be 0, and Q plus R will be minus 1, and R plus P will be 1, and that will be 1, 1, 1. Okay, you can open it along column 1, so minus 1 into, I think complete it comes out to be 2, you can check, minus 1 into minus 2, yeah. And from this, if I put P as 1, Q as minus 1, R is equal to 0, you can check this also comes out to be 2K. Let me check. P minus Q will be 2, and Q minus R will be minus 1, and R minus P will be minus 1. So that will be 2K. Hence the value of K is coming out to be 1. Okay, in fact, let me tell you, this first determinant delta 1 can also be solved same way if you don't remember this result. Okay, but that is something that is very standard, you should remember. So answer will become delta 1 upon delta 2 as 8, because K is equal to 1, all the terms will get cancelled, so this answer has to be equal to 8. Okay, so this completes question number 13 also. Okay, now moving to next question, that is question number 14. Okay, question number 14, we are given A as a diagonal matrix in which diagonal elements are sine square alpha, sine square beta, sine square gamma. Okay, and B is also similar to that, 10 square alpha, 10 square beta, 10 square gamma in diagonal element, rest all are 0, 0, 0. Now please listen carefully. For such questions, there is something that if you remember, then it's very easy, that for diagonal matrices, their inverse is nothing but you just take the inverse of diagonal elements. It will be actually cosecant square alpha, this 0, this 0, this 0, and this will be cosecant square beta, and this 0, then 0, 0, cosecant square gamma. Okay, likewise, if you are finding B inverse, it will be cot square alpha here, cot square beta here, and cot square gamma here. All remaining elements will be 0, 0. Okay. One more thing, if you are looking for a power minus 3, if you are looking for a power minus 3, it is nothing but placing cubes of diagonal elements. That means it will be cosecant raised to the power 6 alpha, 0, 0, 0, cosecant raised to the power 6 beta, 0, 0, 0, cosecant raised to the power 6 gamma, and similarly beta power minus 3 also. I am not writing, you can imagine, you can write yourself also. Now if we know A power minus 3, we know B power minus 3, okay, and we can see all such matrices are which are having non-zero elements along diagonal only, all other elements are 0, 0, 0. Then if C is given like this, I think C will also have non-zero elements only along diagonals. All other elements which are not on diagonal will be 0 everywhere. Okay, now to find the value of C, what we can do, let me write just one element of C. Let me write just one element of C, that is C11. Okay, how this will be found that one element of a power minus 3 I am just considering here, that is cosecant raised to the power 6 alpha. Okay, then minus beta power minus b power minus 3, that will be equal to minus cot raised to the power 6 alpha. Cot raised to the power 6 alpha, because beta b power minus 3 will be here cot raised to the power 6. Then plus 3 times a power minus 1 means cosecant square alpha. B power minus 1, this element will be cot square alpha. Yes, one more thing maybe that I should have told you before, that when you multiply a power minus 1 and b power minus 1, and because they are diagonal elements, you will find your 1 element will be the multiplication of respective 1 elements, and all other elements will be 0, 0. You can check when you multiply first row with the first column, your first element will be cosecant square alpha, cot square alpha, other element will be 0, 0. So for a power minus 1, b power minus 1, it will be like this only. And then further, if you multiply b power minus 1 minus a power minus 1 with this, again their 1 elements will get multiplied. There is no need to do the complete multiplication, you can say. So b power minus 1 would be cot square alpha minus cosecant square alpha. That is my b power minus 1 minus a power minus 1. Now if you check it, all of you, I think it is nothing but cosecant square alpha minus cot square alpha whole cube. You can check. It is nothing but cosecant square alpha minus cot square alpha whole cube. If you open it, you get cosecant square alpha whole cube, cot square alpha whole cube with minus sign here, then minus 3 times AB, 3 times cosecant square alpha, cot square alpha into cosecant square alpha minus cot square alpha. But here order is different, that's why there is a plus sign. I am talking about the expansion of a minus b whole cube. Let me remind you, a minus b whole cube is what? A cube minus b cube minus 3ab into a minus b. So it is same as this thing. So your 1 element is coming out to be, I think, 1. Is that correct? Because cosecant square minus cot square, you know, it is one identity. Similar to this, the 2 element and 3 element, they will also be equal to 1, because there you will get beta, everywhere beta only, and you will be getting this identity only. Hence C11, C22 and C33, they all are 1, 1, 1. Then I think you can find the determinant of matrix C, because C is nothing but C is actually nothing but C has become now 1 0 0 0 1 0 0 0 1. So this determinant of C, that is what we are looking for, will be equal to 1. So that is the answer, bacho, for this question, 1. Okay, moving to the next question. I think that's the last question of this paper. If the ordered triplets XYZ satisfy the equation, we have to find mod XY plus YZ plus ZX. Now the question here is based on the range of inverse trigonometric functions. Please see how. You know, sine inverse X, the range is minus pi by 2 comma pi by 2, close bracket both sides. Okay, which means sine inverse X whole square will take values from 0 to pi square by 4. It cannot be more than pi square by 4. Whereas on the right hand side you can see pi square by 4 plus some positive quantity, positive or 0 you can say, and here also positive or 0. Now both sides can be equal only if you take maximum possible value of sine inverse x whole square and you take 0 here and 0 here. I hope you all are getting what I'm saying. So sine inverse x whole square will be equal to pi square by 4. That means sine inverse x can be either plus pi by 2 or minus pi by 2, and that will give you x equal to plus or minus 1. Likewise, secant inverse y will be 0, so y will be equal to 1. Okay, and tan inverse z, secant inverse y is 0, so y is equal to 1, I think, yeah, 1, and tan inverse z is also 0, so this z will be equal to 0 here. So x is plus minus 1 and z is 0, so this xy plus yz plus zx which we are looking for will be equal to 1. Can I write this directly? Because if z is 0, it will make these two terms to be 0. Only xy we have to take care of, and mod is also there, so answer is 1, whatever you take. Okay, so this is the last question. Okay, so this completes the solutioning of this paper 1 of Eklavya entry test. I'll be coming back for Eklavya entry test 2 very soon. So thank you so much all of you.